All right, welcome back to the next Nix Hour. Should be working, and today I'm not going to stream the video to Jitsi. Hopefully that will fix some stuff. So please watch on YouTube. But chat, we're still going to use Jitsi chat. So if you have a question, please use that chat by joining the meeting. But so today we will look at python.withPackages. How does it work? There's some questions here by someone, and we're going to try to answer them. So maybe let's start out by just looking at the wiki here. I mean, the wiki often has outdated information, but this hasn't really changed much, so I hope it's correct. Although generally we should prefer looking at the docs and improving the docs when they're missing or wrong. So I'm going to look at the Nix packages manual here. With packages, so with packages is a very generic thing. You have it for a lot of package sets. We can see here GHC for Haskell. What else is there? Agda also has one. It's kind of become a convention, although I can't say that all of them work exactly the same. Here we can see high derivation. That's something else. Here, list modules also has one. Build wrappers. Okay, I'm going to search for python.withPackages. Oh, here, section python.withPackages. So provides a wrapper, simpler interface to the buildEnv functionality. I guess we would have to look at what buildEnv does then. Python environments can be... doesn't really say what it does, really. Does it show you how we can use it? Not really. Oh, and the with packages is right down here. Well, with packages passes the correct package set for the specific interpreter. Okay. Yeah, so we can kind of guess the functionality here. Packages to be created. Yeah, it doesn't really say what it really does. But what it does is that it gives you a Python that has all these packages that you pass in scope. And so we can select the ones we want by this lambda here, this function, and yeah, it will only use those. So I mean, let's just give it a try. I'm gonna go Nix Hour 58. I should use my template maybe another time though. So let's do the usual kind of hacky impure import of packages. And the packages.python 3, so Python, kind of a long story, but Python is still the Python 2 interpreter. And it's kind of hard to deprecate it. But so generally you want to use Python 3 instead. So we're going to use with packages. And now here, let's see. Can we get back to the section? I guess not. Python.withPackages here. Okay, so generally it's named PS, and then we pass the list. So PS is the set of all Python packages for Python 3. And so in here we can select anything we want. So I'm gonna pick requests. It's kind of the, I don't do Python coding a lot of times, so this is kind of the default library I use to showcase. Okay, let's try this out. 58. I mean, I think if you've used Python in Nix before, you've probably seen this function already. But then I'm just going to build this expression. It's going to return or build this one here. Let's see what it contains. Let's make this a bit bigger, like this. This is... we use tree instead, tree result. That's a bit better. So, well, we have bin, we have the Python binary. I have some others, I don't really know what these are. But yeah, mainly we have Python binary. And we can call this result bin Python 3. Python 2 would be, or Python without 3 would be the same here. And then we can do, I guess, import. Okay, I don't actually know what requests exports. Let's actually look at Nix packages for this. I know there's an imports check function. Imports check, or check imports, import check, check import. Okay, it's not that. But let's look at the requests library here. See if it has that, what I'm expecting to see. Oh, here, Python imports check. All right, that was it. Okay, so it's called requests. And that seems to work. Requests dot, and we have request stuff. All right. And so this also works for various others. So you could say, maybe an interesting example to see would be, do we have the dependencies in here? Like IDNA, import IDNA, seems to be. So Python apparently adds probably all the dependencies and the transitive dependencies as well. And I guess that's needed just by Python, just because how Python works. And so we could add more things. That's the basic thing, how it works. And maybe to just like look into how it works, let's look at the binary itself. So that would be Python here. And that is an ELF binary, so we can't actually see a whole bunch here. Let's actually see, is there? Oh yeah, here. Oh yeah, this. So since recently, like a year ago, we have a new kind of binary make wrapper version, which doesn't create a shell script, but it creates an ELF binary. So it actually builds some C code, some like very simple C code to do this kind of wrapping, like it sets environment variables before running. It can also do other functionality, and to actually allow people to see what's up with that ELF binary, it gets like this information gets inlined into the binary. And so we can see here, blah blah has been generated using the following command. Use Nix shell make binary wrapper to get access to make C wrapper. So we can see here, it's a wrapper around this Python binary, but it sets some extra things. So Nix Python prefix, Python executable, Python path, and Python no user site. And I guess the most important one here is this one, the Nix Python path. And I believe this is the same derivation we're in right now. So Python 3-env here, and the side packages under here. So if we go look into result, lib Python 3.11, oh, side packages, yes. If we go in here, this is apparently effectively the Python path. So we can see here we have requests, we have IDNA, we have all the other dependencies and reverse dependencies. Well, that doesn't explain the entire thing, because if we look at this again, it sets Nix Python path and not Python path itself. So we need to figure out what Nix Python path is, and so I believe this might be another wrapper, so kind of doubly wrapped, let's take a look. And actually, we also have this executable. Let's also take a look at that. But for now, I'm going to look at the original binary here. So it's also an ELF binary, and I don't see any kind of make wrapper thing. So this looks to be something else. Okay, let's look at Nix Python executable. We might have to look at the source code as well to figure all of this out. Oh yeah, this is another wrapper. Is it? Oh no, this is the very same executable we are looking at right now. So I just opened the same file twice here. Okay, I think next step, let's just grep for this. I'm in Nix packages here. Let's grep for Nix Python path. I'm gonna reorder my Windows a bit. And here, well, we can find the source here, Nix Python path. So this is the make wrapper incantation. Python that looks to be correct, although it doesn't use make C wrapper. Although make wrapper might be an alias to make C wrapper. So, oh, okay, yeah, make binary wrapper. Apparently, if you add that to native build inputs, I'm guessing make wrapper is an alias for make C wrapper. Okay, but where is it actually used? And I think site customize, that I believe it might be that. Well, let's read a bit. So this is a Nix specific module for discovering modules built with Nix. That sounds pretty good. Recursively adds paths that are Nix Python path to sys.path. I guess this is how Python underneath discovers the packages. In order to process possible PTH files, I believe, I don't quite know what these are. I might be related to editable or kind of external dependencies, something like that. At site dir, the path list added to. Okay. Yeah, that sounds pretty good then. So in here, a fairly simple code reads the Nix Python path variable. I guess this splits it into all the entries and then adds all of them to sys.path. Oh, well, site.prefixes, something like that. Don't want to dig into too many Python internals here. And yeah, so that's, I guess, how it works. It's a bit, I'd consider this a bit hacky. I don't think Python was kind of intended to be used that way. So every time you use buildEnv, I guess, it's the underlying function. So, right, we could also use buildEnv directly. I think that would be python3.buildEnv. And the docs, we'd have to use it. Look at the docs here. .buildEnv. buildEnv, oh, I see, the interface uses .override, which is a bit weird, but that does work. Let's actually look at that just to see how the definition looks like. So we're in the, that's all the kind of Python setup code. I believe buildEnv, let's, here this sounds pretty irrelevant. buildEnv, so the Python ecosystem is a bit weird because you have everything kind of nested under the Python attribute itself. In other kind of parts of Nix packages, you don't really have that. You have, for example, Haskell or GHC rather, then you have packages.haskell packages, which are kind of separate, or there's also packages.haskell. I believe then the version, and then the .packages or GHC, something like this. But in Python, it's kind of nested under the derivation, which is the interpreter itself. And so this pass-through fun here is, well, this is implemented using pass-throughs. Pass-throughs are attributes on derivations that don't affect the derivation itself. So this is how, well, it's a function in this case. It doesn't really make sense to propagate that into the derivation. And so when anything with this function changes, it doesn't affect the derivation. And so that's kind of good. And yeah, that's why it's called pass-through fun. Well, fun for function, not for fun. And we have some more things here. We have, well, let's see, we have buildEnv. So I presume all of these are available on the Python 3 attribute. Let's just make sure of that. So I'm just gonna Nix REPL and load Nix packages. Let's move this up here. All right, so Python 3.buildEnv. Okay, we have buildEnv. What about is py2 27, yeah, these exist. False is pi3, true. Yes, all of these are available on all the Python interpreters. So right, we could also use Python 3, Python 2, and right, so these always use a correct Python interpreter, of course. So if we use buildEnv, that's going to build one for Python 2. Okay, and so buildEnv is declared using this wrapper here. It passes Python in all the Python packages, acquired Python modules. Not sure what's up with that, but a wrapper here. So actually, if we go back, we can see it's a call package. So call package is actually what adds the .override that we need to use. So this is why it's kind of weird. So usually you'd have an actual function, and so it might be like this actually. Yeah. Usually it would look more something like this, where the first set of arguments are passed with call package, while the second ones are kind of meant to be called as a function. And but in this case, that's not done. And how you override the call package arguments is with .override. So Python 3.buildEnv.override, and now Python, I guess that's also passed, well, it says manually passed, but it's really passed automatically as well, because Python is a global attribute set, a global attribute. So all of these are passed using call package by default. We could override this though, but I don't think that would make a lot of sense here, because we have Python 3 kind of already specified here. Right, and then we could use extra libs here, so that's a thing to override. We could also use the old value, like in this case it doesn't really make sense, but we could also say old and then extra old.extra libs plus something that would work. And that is actually sometimes useful. So for example, if we have so let's say we declare this python.env here, right here. Oh, and just for anybody joining, maybe you can put this in chat that need to use the YouTube stream to see what I'm doing. So, okay, we put the env here, but now let's say we want to add more packages to the environment. And so I presume that extra libs is how withPackages is implemented. And we can actually look at this as well. So withPackages, it's here. withPackages equals, okay, it links to withPackages, but it also, we can see here, it passes in buildEnv. It's kind of weirdly inconsistent here that this uses import now, but that's fine. And yeah, it's a super simple wrapper over buildEnv, so it really just does that, but a bit more convenient. So yeah, we could say, okay, well, we want to add some other package, and I guess let's add pyramid here. Now, if we were to just say .override and then extra libs equals, I guess in this case, we need to use Python 3 packages. And actually, I guess that's a good reason why you'd want to use withPackages, because now we have a kind of duplicated reference to Python 3. We could do it like this, Python 3, and then Python.withPackages, and then Python.packages. That's another pass-through attribute on the Python interpreter. So we could use that, and then access packages through that. That at least gets rid of the duplication locally here. So pyramid, let's use that. But once we try that, Nix build, NB is my alias for that. If we try this then, import requests, yeah, request is gone. So yeah, we have to use old or maybe a better name, kind of more conventional, or maybe becoming more conventional would be prev attrs here. So these are the previous attributes passed to the, well, maybe args would actually be better. I'm not sure. But we can use prev args dot extra libs plus and then the extra ones. It's kind of recursively extra here. It's kind of weird, but sure. Now let's try this. And now we should have requests and we should have pyramid. Not sure why it doesn't, I don't have any auto-completion for these modules. Maybe that's just not what it provides. Okay, let's actually jump back to the issue here. There's some questions here that were written down. We can see here there's with packages, and right, you can then put this into system packages. It's like any other derivation. Make sure you add the parentheses front and back, otherwise this becomes a list of 2 elements, which is usually not what you want. Oh, here, I mean, this is a question. I think it has been answered kind of below, but let's also answer this. So why does it have all the packages? So PS, and maybe, I mean, let's go back here. Let's do kind of extra packages, call it that. But we're going to evaluate the env here. And so let's just see what PS is here. And so maybe a good way to do that would be lib dot debug dot, so we want to trace it. We don't want val. Val returns the same thing that we trace. So we actually want the trace sec variant, which traces something and then returns the second argument. I'm gonna structure this a bit better here. And I could actually also, well, let's keep it at that. Let's get a lib in scope here, and there's some, inherit, not import. Inherit lib. Okay, now this needs 2 arguments though. So the first one will be PS. And actually, I'm going to use sec n version here, so I can pass the kind of levels of recursion that I want into PS. So we don't actually want to evaluate all the packages and trace them. Just want to see kind of the top level attribute set. Actually, we can't really see that if we do that. Yeah, so it's just going to print ... So I think we'll have to increase this by 1. And then we can't evaluate it anymore. Yeah, so let's say PR to trace sec n, because it has actually, like, this has all the information about the attributes, it just doesn't print them. So I think we'll have to use something else for now. I'm gonna print switch to sec, and now let's just I could filter them, but that's a lot of evaluation time. So I mean, in Nix, maybe just briefly, if you have an attribute like a equals 10, okay, that works. You can say, well, let's actually have a thunk here. That doesn't work. Let's see, like, let's say f is like the identity function. Now let's say f20. Oh, that also works. Just evaluate this strictly. Well, so, okay, the main thing I want to show is that if you have a throw here, a, that doesn't work. The REPL is a bit weird, but you can, let's do a buildEnv.sec. So sec evaluates the first argument, like not deeply, and then returns the second one. So we can evaluate this. And oh yeah, also we can evaluate the attr names of this. And actually let's use trace, buildEnv.trace. So here we can actually get the attribute names without accessing the values at all. So if we were to access the value, it would give an error, but it doesn't, and so it kind of works. And but yeah, so apparently lib.debug.trace_sec_n doesn't do that. It just prints ... It kind of ignores this list here. But so let's print the list of packages kind of more manually. So let's say lib.attr_names. So let's get all the names. And well, maybe first of all, let's get the, or let's do it like this. Let's print the entire attribute set here. And let's say the type buildInst.type of PS. Let's maybe start with that. So I mean, we've kind of seen it already. I'm going to use Nix instantiate now because I don't actually need to build it. So yeah, it's type set. Okay, well, set is kind of a different name for attribute sets. And so types, and then let's say attributes is built-ins. Well, we don't need to use built-ins. We can use lib.attr_names of PS. Okay, and now we actually get all of these. Okay, so that's a lot. Let's maybe just print the count of these. I believe is there, oh well, there is count, but it doesn't really do that. In this case, we just want length. The length of the list. And let's actually change this count. All right, yeah, so this is all the packages, and we can see it's a set. And so maybe the question here is, well, the question is, why does it have all the packages? That's, well, all the packages that Nix Packages knows about are passed in there. So if we look at with packages, let's maybe trace this back to the kind of root. So we have with packages, and how is this done? So here's a function we pass in. So the f here, in our case, well, that's like ps something, ps.foo. And so if we pass the Python packages argument to it here, it's going to be, well, ps will be Python packages, like this. Okay, then Python packages comes from up here. Where does that come from? With packages, Python packages. Okay, I'm going to cheat a bit here and use nil, the language server I use, to jump to the definition. Okay, it comes from here. It's defined as a bunch of, or a let in, and then we have ensure Python modules. Not sure what that is about. Is that really it? Hold on, I have to make this bigger. Python packages, let in ensure Python modules call package. Oof, this is hard to read. Well, it's actually this. So it's call package, and then we have let in here, and then it's a make scope with splicing. The splicing is for kind of cross compilation to work correctly. And well, the this is the real underlying. Well, is it? Wait. Python overrides lib.extends. Yeah, I think this is where the packages actually come from. Really hard to read. But then Python packages fun comes from here. Oh, and also we have these overrides, but I guess these are not relevant to get all the packages or all the base packages. So we jump to the base packages. We see Python packages self. This is messy. Python derivation. I'm not sure if this is the right one actually. Python packages fun. I mean, somewhere here, this should be what we should get to eventually. Oh, Python extension. Okay, so Python extension, and then that's used in extensions. Oh, and extensions is passed here. So, okay, that's kind of where all the packages come from. it's very hidden, right? And this is the long list of all the packages where you need to add the packages to Nix packages for it to know about them. Okay, so I think that's enough browsing source for now, but I think that explains it fairly well. How does Python 3.8 install exactly what I choose? We covered that, I think. So there's a lot of text here, but there's some questions in italic here. And you can read this as well if you're interested, but I think let's jump to just this here. Why pass through, by the way, is the only reason for that is because with packages is a function. I still understand pass through pretty poorly. That's one reason. So we can't, well, actually, let's look at a package. So let's say, I mean, Python kind of looks like this. So fake Python. And so we need packages, std make derivation. You know, everything is based on make derivation underneath. Make derivation is also what implements pass through. So it's not something that the underlying, so make derivation is based on built-in.derivation, which itself is based on built-in.strict derivation. But this doesn't have pass through. It's implemented by make derivation. And so if we just build, well, let's say name fake Python, and now I need some, let's say build command. Build command is a single attribute that kind of overrides the entire build, right? The build command, how to build the derivation. So when you specify this, you won't have any phases or anything like that. So it's kind of a, well, it's not very conventional. Honestly, I wouldn't recommend this, but it works in our case to just showcase it. And this way we don't need to like specify the source, specify the unpack phase, stuff like that. So I just want to build this. Let's build it by just doing this. Maybe actually I kind of want to introduce a kind of convention for testing that I use a lot. So rec is often mentioned as kind of an anti-pattern, and that is true in a lot of cases, but I think for just kind of having a quick cycle of things, it's very useful, because now we have essentially let in, so all of the variables are available everywhere else, but we also have access to all of these. So I can now go in here and say nix build -a fake Python, or I can also say nix build because I mean, lib is available here, so I can say lib.I have all of these. I can do python.packages and just be like build requests directly, for example. So it's just kind of useful to use rec in this way. But make sure if it's the right choice when you actually want to upstream code like that. So build command. Okay, let's build fake Python. I think I did it already. So fake Python, and that's currently empty. Okay, and now let's kind of simulate actually building Python, kind of very simply with a sleep 5. So it's taking some time. Okay, and yeah, let's also do an echo. Building Python, wait 5 seconds. So yeah, that works. Seconds. Yeah, but now let's presume that we want something in the result. So actually, let's load this into Nix REPL, the current file, or the default.nix, and let's say fake Python, and let's see what's available here. And so it's a lot. Can I get some like 2-page completion? I can't. Okay. So there's things like ignore nulls, structured attrs, all comes from derivation, args. That's not sure where that comes from. We have our build command. So we can actually just look at this build command, see what it does. Yeah, builder is the underlying builder, so the build command is executed by the underlying builder, which in this case is bash. And so, yeah, these are kind of all the attributes on the derivation. Now, maybe as I note here, ideally we wouldn't have that, because a lot of these are kind of internal and not really meant to be exposed, right? Like build command. This is not something that can be stable. Like in a future version, we might just switch to phases, and then the build command wouldn't be there anymore. So there's been a PR to Nix Packages, which is, I think, in a draft state right now, but with the or closed. But it's the idea is pretty good to not expose all of these attributes by default, and so really limit it to a small set of them. That would be like outpath. Outpath is a thing that allows you to coerce these values to strings. Right, so if we have fake python.outpath, that's this, but we can also just do kind of string coercion and we get the same thing. And I believe toString also works. Hold on, toString. Yeah, toString also works. Yeah, so kind of keep these. Maybe output name is important to distinguish multiple outputs as well, but most of them shouldn't be in here. But so we have now, let's say we want to propagate one of these. So most of these are internal, but the kind of pass-through use case is that you actually want public ones for these. And so we might say, let's say Python interpreter name. I think that might exist internally as well, but let's use it here. And so in this case, let's just say it's Python 3 compared to Python without a 3. And if we add this here, and let's reload in the REPL, fake python.python interpreter name, that works. But if we try to build this, it's gonna build it again. And that's because any attributes you add here also get exposed as environment variables to the builder. And so yeah, we can see this in here by seeing that Python interpreter name, or name is this. So if we build this, yeah, we can see name is Python 3. And so we don't want this. There's no need for this to influence the build. It's only meant to be, well, in our case, a thing people can use on the resulting derivation value. And so, yeah, that's why pass-through. So pass-through kind of circumvents the derivation function. So right underneath, implemented as derivation, but pass-through gets around this. It doesn't pass this to derivation, but rather just kind of adds it on top. And so if we try this, well, let's try this. Hold on, no, this shouldn't build it. Hold on. Oh, did I change something here? Well, let's just confirm. So, yeah, okay, it apparently wasn't built in that exact configuration. Now let's add the pass-through, and we can see it's the exact same hash. So it could reuse build result, the derivation didn't change. But we still have this one. So pass-through dot, all of these attributes get exposed directly on here. You can also use, you will sometimes see pass-through dot. This also works, but it's not really meant to work that way. So you shouldn't need this. Yeah, and actually maybe we could let's do like a very simple implementation of pass-through. It's kind of interesting to see how it actually works. So let's say my make derivation, and then let's say address here. And now we want to call built-in stop derivation. Okay, now actually, yeah, we want to pass all of these to the derivation call, except pass through. So we want to do a remove address. I'm not sure if that, I don't think that exists in built-ins, but my highlighting kind of implies so. So let's try it. I keep forgetting the order of the arguments for remove address. I'm just going to pretend it's this way. So we're going to remove pass through. It doesn't fail if it doesn't exist. Okay, so we don't pass that, but then we add it on top of the result. So address.pass through. But if it doesn't exist, we need to handle it here. So we just add empty ones here. And actually I'm gonna hold on, no. Format this. Well, kind of looks the same. I guess I have it on really high, big font size. Anyways, so I think this is pretty much an implementation of pass-through. Let's try it out and my make derivation test. So we're going to call my make derivation. Now we don't have, so build command, that's a make derivation thing. We didn't implement this. So we have to do the kind of bare built-in derivation thing, which is builder. In this case, I'm going to kind of cheat and use packages.bash. And I need to give the actual binary name here. So sure, bash. I need args. These are the arguments passed to the builder. I'm going to use -c to pass a script and then just do like a touch of out. So out, that's a built-in derivation thing. And we also need a system. If we don't provide that, it will error. So I'm just going to use built-in current system, or let's keep it this. Okay, make derivation test. Now next build make derivation. My make derivation. My make derivation test. We need a name. Test. All right, we have touch command not found. Okay, that's fair enough. Could probably set an environment variable like this. Does that work? Well, let's try it out. I'm going to use lib.make bin path, and then touch. That's probably from let's see, real path, which touch. That's usually my way how I find where things come from my local tools, and so that appears to be in core utils. All right, packages.core-utils. Let's try it again, and it works. And if we do a pass-through thing, pass-through test equals 10, that still produces the same derivation. Yeah, and also I kind of want to try out something here. What if we pass bash in the path and then just, I don't think this will work. I think this needs a full path, but let's just give it a try. Yeah, bash no such file or directory. I guess it depends on where this executes stuff. Maybe, kind of a long shot, but maybe we could hack around this by saying that packages.path. So this is the it's not path. This is the path to bash. If it executes it in like the root path here, maybe this will work. Don't ever do this. This is terrible. But for my curiosity, let's see if that works. And let's remove this for now. And no such file or directory. Okay, it's probably somewhere else. I don't really want to dig further. Okay, so that works. And yeah. Okay, let's go back here. So we have y pass through. And right, functions. We can't actually pass functions to derivation builders. So if we tried like the previous approach of saying, let's use the fake Python here instead. If we try to do with packages equals, and then we could do our own thing here. Sure, PS, and then, or this would be F, and then we call F with the python.packages. And then we create a buildEnv from that. That would be python.buildEnv, and then dot override. Well, the thing we kind of saw before. Extra libs equals, I believe it's this. Yeah, something like this. But this doesn't work because functions aren't serializable to arguments. Yeah, so can occurs a function to a string, so it tries to put all of these as environment variables. And I guess we could imagine like a Nix to bash compiler to actually have this be available in bash, although that doesn't really make much sense, I guess. But yeah, so we need pass through for these. It's unavoidable. Yeah, so let's jump to this one down here. Required Python modules. All right, we saw that as well. Let's just jump to this one briefly. Required Python modules. Yeah, we saw this earlier. I was wondering what's up with this. Defined here, and they link us to the definition. Filter has Python module. Okay, let's maybe read the full question. Does it like go through the tree of Python dependencies of the past derivations and just combine them into a new list of all required derivations? So it looks like this is not influenced by the actual function. So we have with packages, we kind of wrap her around buildEnv, and only with packages knows about this function and which packages are actually required. And that's this. So right, the function here passed by the user then selects the ones the user wants. But buildEnv doesn't really know about this, like extra libs contains them. And so the buildEnv here, that seems to be completely something different. So I guess let's see what's up with that. And let me open this in here. Packages base required Python modules. So what does it say here? Get a list of required Python modules given a list of derivations. It's not immediately obvious. Maybe something that I do know is that Python packages can either be an application or just a package. Applications are, I think, generally have binaries, probably. But we can, I think there's some pass-through attributes that can tell about that. And oh yeah, we have done here. We have two Python modules. So this makes a generic derivation kind of have the signals that it is a Python module. And so apparently it sets some pass-through, so it doesn't actually modify the derivation itself. So Python module, not sure why that's a module, because this is the Python like interpreter. Not sure what's up with that. This is deprecated, and this is required Python modules. Yes. Okay, propagated build input. So it seems to be. So propagated build input is how Python determines the dependencies. And so in all of the Python packages, you'll see propagated build inputs. And so it might like create a closure of all the Python packages. Let's see what this function does. Well, right, that's the one we're actually wondering about. So, oh, I guess, yeah, I kind of see what it does. So it looks at the derivations. It filters for the ones that actually have a Python module. So that's the attribute that gets added down here. And so all the Python dependencies in Nix packages probably have that. Oh yeah, okay, that's I think our clue, because let's look at python.packages and do like a all Python attributes or attrs is lib.attr, or let's keep it like this. Well, don't really need it in this case. Python.packages, and now I'm gonna use, I want to remove all the modules. So I'm gonna do only Python modules equals lib.filter attrs, and now I'm gonna use that's has Python module. So that should be python.has Python module. I hope that exists. Python.packages. Okay, only Python modules, and now let's see. Well, yeah, only Python modules. Let's see attribute names. Has Python module missing? So it's probably, where does that come from? Does that has Python module? Oh, that's probably something on the packages. Yes. Well, oh, it is. But we can't evaluate all of them. And we kind of need, well, do we need, I guess we kind of need this, yeah. So how does this actually work? Like, wouldn't it also fail if it passed all its modules? So the kind of thing I want to do, and actually maybe we can do this way, so wait, only Python modules, attribute names. We only want to evaluate the attribute names. Yeah, is it maybe these are not all the packages. Maybe these aliases are kind of pre-filtered. This is a bit weird because like this sounds like it would be very expensive. Oh, actually no, it should be fine. So has Python module only looks at this Python module attribute. It doesn't need to evaluate the entire derivation. So in particular, it doesn't need to evaluate outpath. So if we go python.packages. I don't know, TensorFlow, a big package, and we just look at Python module, this evaluates pretty quickly. If we look at outpath, oh yeah, this is much slower. So just accessing Python module doesn't need to evaluate the derivation. Only outpath and I think drvpath need to evaluate the derivation. Well, now we have it cached. It was much faster. Okay, and so I guess in here or somewhere it filters out the. Does it really though? Let's look at the use side again. Pass through fun required. Oh, right here it's not a function, it's an attribute. Right, so let's jump back. Oh, this is a kind of hard to look into. Oh, okay, I see. So this, I think, is this the attribute that we're looking at? Inherit required Python modules. Oh no, sorry, I said something wrong here. Required Python modules. Yeah, I've gotten a bit distracted. So, right, this is a function. It's not a set of Python packages. So with that in mind, let's look at this again. Required Python modules. Right, and so, okay, that makes a lot more sense. So in here, right, it only uses the packages that are actually needed. So, okay, we found the link, extra libs, and required Python modules. And so finally we can kind of test this. So I guess I want to see what isn't a Python module from that list. So if we like went into here and said like, okay, filter, let's do filter directly. Or I guess we can use the function directly. So python.packages.required Python modules. And now let's pass in like, let's pass something big like packages dot or python.packages.tensorflow. I think this might, I'm not sure how many Python dependencies that has. Okay, that's a list. I kind of want to now see which ones aren't. That might be a bit harder though, because in here, filter has Python module DRVs, and so does it call this recursively? We have modules. We have it adds Python, it adds modules, it adds concatlib, cat address. Oh, yeah, it calls it recursively because required Python modules is then defined like this underneath here. Oh, and I guess this is a subset of the propagated build inputs. That kind of makes sense now. So you could have propagated build inputs that aren't a Python dependency, like a Python module. And so the required Python modules only returns the ones that are Python modules. Kind of makes sense. I wonder if we can actually find a case like this. We could do like, let's see, Python packages and well, I think this might be a bit tricky. We are like out of time here, so I think we'll cut it here for today. I'm glad I caught my mistake there just in time. That required Python modules is actually a function. Well, it's both a function and an attribute set in this case. Well, it's a list in this case, but a function in this case. Yeah, but I think that covers it decently well. I hope you enjoyed, and I'll see you next week, hopefully.